suppose the equation of the form f of r, theta and c equal to 0. This is the polar curve of the form. Then to find out the perpendicularity or orthogonal trajectory, we must replace dr by d theta equal to minus r square into d theta by dr. Find the orthogonal trajectories of the family of curves, r power n equal to a power n into cos n theta. So here solution, we differentiate with respect to theta. So here we must differentiate the power n into r power n minus 1. Then we must differentiate r also with respect to theta. We are getting dr by d theta equal to a power n is constant, cos n theta is minus sin n theta into n. Here we can cancel n. We write it this as dr by d theta equal to minus a power n into sin n theta dividing by r power n minus 1. Orthogonal trajectory. To find orthogonal trajectory, replace dr by d theta as minus r square into d theta by dr. So here I am only replacing the left hand side, dr by d theta. I am writing this as minus r square into d theta by dr equal to right hand side a power minus a power n into sin n theta dividing by r power n minus 1 is that. So here minus minus get cancelled. Here we can cancel minus. Here d theta dividing by dr equal to, otherwise we can modify. Here we keep theta left hand side, then this one right hand side dividing by sin n theta is there, so bring it to left hand side. We get sin n theta in the denominator, and right hand side we get a power n into dr in the numerator, and r square bring it to right hand side, it become r power n minus 1 into r square. We can write it as dr dividing by r power n plus 1. So here we do the small modification, d theta by sin n theta equal to right hand side a power n into dr dividing by r power n plus 1 is there, we write it as r power n into r. So here a power n into dr dividing by r power n is given quotient a power n into cos n theta into r. So here we can cancel a power n, and this one we cross multiply, we write it as cos dividing by cos n theta dividing by sin n theta into d theta equal to dr by r. So here we do the small modification. This one is cot n theta into d theta equal to dr by r. So here if we integrate this one, we can write it as log r equal to, this is log sin n theta dividing by n plus constant, we write it as log b or log c. So here we take the LCM, we write it this as log sin n theta. So this is sin n theta plus n into log b equal to n into log r. So by using the power rule, we can write it as log sin n theta, and here we can write it as this as log b power n equal to log r power n. So here we have the term, this can be written as b power n into sin n theta equal to log r power n. Now both the side log term is there, we can write it as b power n into sin n theta equal to r power n. So this is nothing but orthogonal trajectory for the given curve, for the given curve r power n equal to a power n cos n theta. Show that the family of curves r equal to a into sin theta plus cos theta and r equal to b into sin theta minus cos theta intersect each other orthogonally. So here family of curves is there, we must use the orthogonal trajectory. So here solution, we take any one of the curve. So let us consider r equal to a into sin theta plus cos theta. Differentiate this one with respect to theta. So here r can be written as dr by d theta equal to a is constant into sin theta. Sin theta differentiation is cos theta plus cos theta is minus sin theta. So now we must replace dr by d theta as minus r square into d theta by dr to find OT, orthogonal trajectory. So here I am modifying the left hand side, r square minus r square into d theta by dr equal to a into cos theta minus sin theta. So here we modify this one, we write it as d theta minus 1r, we keep it as it is, dividing by a into cos theta minus sin theta equal to dr dividing by r. So here this minus is multiplied here, we get d theta dividing by, here r is nothing but, from the given question we can write it as a into sin theta plus cos theta, and here we have a into cos theta minus sin theta. So here minus is the equal to dr by r. So here we can cancel a, and here if we multiply minus in the denominator, we get sin theta plus cos theta into d theta by this one denominator, we get sin theta minus cos theta equal to dr by r. Now we integrate this one. So here we can write it as log sin theta minus cos theta. So here differentiation is 1 by sin theta minus cos theta, and sin theta is cos theta minus cos theta is minus into minus is plus sin theta. So we get plus log k equal to log r. So here plus is there, we can write it as log k into sin theta minus cos theta equal to log r. This is nothing but k into sin theta minus cos theta equal to r. So here instead of k we can write b. So if we write b, so we are getting the orthogonal trajectory of, this is OT of r equal to a into sin theta plus cos theta.